All right, here we have it, folks. Our last section of this unit. We're going to do surface area and volume. Part of this is a review for you. Part of it will be new. Lots of formulas here. You don't have to memorize them, but it wouldn't hurt to know them really well. You'll be allowed, a formula sheet. You'll be allowed to use a NISA sheet, that thing, that sort of thing during the assessments. So, anyway, so we're on to our second part of the second part of the summative, which we're heading towards here. So you would have just taken the first part of the summative. Make sure, again, if you've had questions or mistakes or errors on that or whatever, go back and make some corrections, redo, improve your grade. Because it'll stink if you wait till after this section. I think this whole section, beginning to end, is a little over 2 weeks. Okay, so you want to pause at some point here. Perimeter and circumference. So a couple of words from your vocab in here. As a reminder, the perimeter is the distance around a polygon, and circumference is the distance around a circle. Formulas are pretty straightforward. If it's something that's flat-sided, just figure out what each of the sides is and add them up. So whether it be the 4 sides of a rectangle, the 3 sides of a square. If it's a circle, there's a formula though. You'll remember this from last year. Radius is halfway across the circle. Diameter is if I go to all the way across. So if I give you the radius, you double it, so times 2, and then multiply by times pi. Most of the time for pi, you'll use 3.14. Unless I tell you, something else. But you might also have the diameter instead, right? So that diameter goes all the way across. So D is my blue line here, going all the way across. If that's the case, just multiply the diameter times pi. Again, 3.14 is a good number to use most of the time for pi. And obviously, you'll be using calculators for this stuff. It wouldn't be fair if I didn't give those to you. I should say with one exception. Some of your work I will say leave in terms of pi. And I'll show you what that looks like later. Where you don't actually have to multiply it out. You can say like the diameter, let's say the diameter was 4. You'd say 4 pi. And that'd be it. You wouldn't even have to finish it. So C equals 4 pi. Because pi is actually a number, it's not a variable. Okay, moving on to area formulas. For parallelograms, that's like, ones that look like a bent rectangle. For rectangles, squares, those are all parallelograms. Rhombuses. I think we had all those pretty pictures you drew early on. Parallelogram, the area of that is the base times the height. So area, again, is base times height. Something to be careful of, though. The height is not always the side of it. The height is a perpendicular line. That means 90-degree angle between the top and the bottom. So in this case, right here, the height is, notice here, it's actually found on the inside. It's a 90, remember perpendicular means 90 degrees. So it's a line that's drawn 90 degrees between the two bases. It's not actually one of the sides itself. Those sides are useless in area if they're bent out like that. Now sometimes the rectangle, right, we can have base and height because these two come together at a 90-degree angle. So base and height works there. Square, technically we have a separate formula, right, side squared, but it's really the same thing. You just take the two sides times each other. And don't forget to label too. It's always labeled squared, like it could be feet squared. Oh, I put that over here already, didn't I? Feet squared, inches squared, meters squared, that sort of thing. So don't forget that. That's really important. So a few quick examples to put in your notes. Perimeter, again, is adding up all the outsides. So let's make sure we get all those up here. So if they're assuming there's a 90-degree angle, it's a rectangle, right? This side's 8, so's this one. This side over on the left is 3, so's this one. So you just add them up. You would add up 8 plus 8 plus 3 plus 3 and get 22. And since it's perimeter, it's technically a line. Like you could unfold this and make it a long line. So it's 22 meters, not squared. It's just meters because it's perimeter. That's important to remember too. The area, though, that is the length times the width. So we find area. Area is, again, base times height, we call it too. So that's 8 times 3, which in this case is 24. And again, we label it meters squared because it's technically made up of a bunch of squares. That's really where that comes from. So 24 meters squared. Labels are important. Most of my quizzes and tests, the label is like half of the points, or at least a third of the points. So make sure you do that, please. Area of a triangle, it's really similar. It's base times height, but you take half of it when you're done. So here's the reason. I'm going to show you why. If I draw a square, right, or even a rectangle, whatever you want to call this, right, base and height, triangle's really just half of it. So it'd be like this half of it. So you take base times height and then multiply it by half. So there's the formula for triangle. Trapezoid's kind of fun. imagine that you guys know what taking an average is, right? So if I had two numbers like 4 and 10, add them together and divide by 2, so that'd be 7 would be the average, right? So what the area of a trapezoid really does, and again, I need you to listen here. Area of a trapezoid takes the two bases. I know it sounds weird to have two bases, but the top and the bottom. These are the parallel sides. That's the really important part here. The parallel sides. Adds them together, here and here, and then divides them by 2, so it averages them. Then it multiplies by the height. Now the thing is, what's really important here, the height is a perpendicular between the two bases. So it's whatever line, doesn't matter if I turn on its side or what I do, you look for the line that is perfectly perpendicular, so that's 90 degrees between the two bases. That line becomes the height. So again, it takes base 1 and base 2, that's the two parallel sides, adds them together, divides by 2, so it averages them, and then multiplies them by the height. And we'll do an example of that, don't sweat it. So as a reminder, area of a triangle is 1/2 base times height. So in this case, we would take, so area of a triangle, I like to draw the picture so I know what I'm doing, is 1/2, and in this case it's going to be 24 times 42, which is 1008. Then you take half of that, so divide by 2, and you get 504. And again, the label, since it's area, time they have area there, is going to be meters, and it's squared. All right, so area of a triangle, put that in your notes. It's a nice example there. Now I did promise you that with a trapezoid, again, you got to look for the two sides that are parallel. Notice here, these two sides. It doesn't matter what I have in these slant sides, and I will include the dimensions sometimes for the slanted sides just to mess with you, but I want you to ignore them. So the bases are the two that are parallel. Now notice here again, I could have taken this, right, and I could have gone like this. So you see them now that they're parallel. But I'm going to put it back like this for you, because it's a good idea to see it like that sometimes. So, and then the height is, again, has to be a line that is 90 degrees between the two bases. So between these two, that line is 90 degrees between them, so it's 9 foot long. So my area, so it takes those two and averages them. So area of a trapezoid is 1/2, and in this case, base 1, doesn't matter which one's 1 and which one's 2. I always call 1 the shorter one. So 4 plus 10, and then multiply that then by the height of 9. So area of this trapezoid is 1/2 of 14 times 9. So 1/2 of 14 is 7 times 9, which we all know is 63. And we're going to say feet squared because it's area. So that's where all that comes from. Area of a trapezoid. Not difficult if you you keep up on them, you practice them here, right? Area of a circle. Okay, we already did perimeter of a circle, right? Circumference. So area is pi r squared, so that radius comes back in. So as a reminder, squared means times itself. So whatever this is, you take it not times 2, but times itself, and then multiply by the 3.14. Unless I say leave in terms of pi, and I'm going to show you that. Then you would leave it there. Okay, so we're going to find circumference and area here. So I included the formulas to help us out. Circumference is 2 pi times the radius, or pi times diameter, it doesn't matter. So I'm going to find the circumference first. So circumference is 2 pi, and then the radius, because it's 12, since they gave me, that's what I'm going to use. You just multiply them out. So 2 times 12, so you multiply the regular numbers. So circumference is 2 times 12, so that's 24, and pi. Now at the end, so if I say leave in terms of pi, you would literally stop right here, and you'd label it, and again, this is circumference, so it's just going to be feet, because it's technically a line, it's not the area thing there. So you could actually stop there if I said leave in terms of pi. So this would be terms of pi. But if I said, no, I want an estimated, I want regular numbers, you would just take and you'd plug in 24 times 3.14. So in your calculator, 24 times 3.14. And you get 75.36. So circumference is 75.36. And we're going to say feet for the circumference. So again, just to make sure, plug in the numbers first, worry about the pi later, because if I say leave in terms of pi, and let's say you forget, let's say you keep going and multiply it out, but you had this included, I'd be able to give you some points for that. So, now then, finding the area, Area is another formula that we talked about, pi r squared. So that means we take, I'm going to grab here, so area of a circle, let me get this stuff out of the way just a second, there we go. So area of a circle is pi r squared, and so pi, we'll leave it as pi. Radius, we already know is 12, so 12, we're only squaring the 12, not the pi. And so 12 times 12, right, is 144. So 144 pi, and if I said leave in terms of pi, you'd stop here and you'd say feet squared. So again, it's not a bad idea to include that as you're working. And then if I say no, I want the decimal, so you take your 144 times 3.14, and you'd get this 452.16 feet squared. So there you go. That's the note, the vocab for this part. We're going to have a few examples. You'll want to make sure you grab the worksheet if you haven't. Just an area review. You did this stuff last year, but I thought it'd be a nice idea to at least spend one day, putting it back in your brain. So.